of the more senior AI people in Stockholm. So it's great to have you here, and fun to hear that you actually had some kind of work recently with stock trading as well. What was that?
Well, it's more something that I do privately after work. When the stock exchange at Nasdaq opens, I trade with tech stocks because that's where I have my interest. And I buy stocks privately, more investing, but actually starting just do a little bit of trading back and forth just for fun, a small amount of time to get a feel for how it works. But invest in a lot of green energy stocks like Tesla, SolarEdge, and other interesting companies with very interesting technology. And typically I look for companies that has some kind of artificial intelligence in it. And that's because this is where I have my edge. I feel that I really can understand and tell if they really have AI or not.
And I guess you use AI yourself to do that kind of trading, or do you do it manually mainly?
Well, actually, it's one of my dream projects, and it's actually not necessarily about trading with stocks, although it's interesting from the point of view that it's something that could help me. But if you look at traditional trading, it's about looking at time series, and you want to basically buy and sell. So algorithmic trading, you use the speed of the computer to trade basically on millisecond basis and even shorter time slots. But what I think is really interesting, so this is for me boring stuff, and making
the high frequency trading part.
And making money per se is not that interesting either. I really like to create things. I believe in creating value and something that is also positive for people. But what's interesting here, economics and finance is really one of the important pillars in our society. And before we started the podcast, we also talked about the importance of having more responsible investing. So it's not only about making money. And to do that, I still think that, we have seen that human decisions have been catastrophic, causing financial crashes several times, and we might see it maybe anytime soon, right? So we need to have a system that can handle this complexity. And so the way I look at it is that you need really to understand the micro level. You need to understand how each company perform. You don't want to have valuations that are run very high. Like there are discussions about Tesla. Is it overvalued, or is it really correct to give it this valuation that it has today? So you have this micro, but you have also the macro that is extremely complicated. You have the politics, you have the economics, and we know that the economics and the financial market are not necessarily connected. You see, there are a lot of companies suffering. The economy is not going that well, but you see the stock market is, going very high. So there are very complex relationships, and this is the part that I'm interested in. And that's why I think neither me or anyone else do have such an AI system, and that's why I have nothing to use myself. On the other hand, I think just starting with having an AI system that collects a lot of news articles and data and try to make connections between different events, so it really can understand if similar events would happen in the future. It can give you some kind of prediction, maybe not quantitative, but qualitative.
But this is AI. It could be stuff like knowledge graph technology, all the things that helps us connect the dots from micro level to macro level to really understand what is really driving the market and a certain stock, I guess.
This is actually, yours really touching on a very deep topic right away,
Cool.
Because we are now suddenly in the realm of discussing, artificial general intelligence or narrow AI.
Yes.
In that sense. And we all know that we are not there when it comes to artificial general intelligence. And there's a lot of discussion about what's the reason, what is really missing. And there are a lot of experts arguing that deep learning it's a great progress. I mean, there's no one who can deny the problems that has managed to solve. But I think when it comes to reasoning, for instance, you mentioned knowledge graphs. I think it's about time to try to integrate it back into the artificial intelligence.
Yeah, well, I mean, like, so we're talking now ultimately AI on the one hand and the deep learning and how we can build models, and we can talk about general models like GPT-3, or we can talk about super narrow, but still in the transformer space or whatever. But how to take that together with an ecosystem thinking, to get that together with a knowledge graph system thinking, and maybe that's also how we create more reasoning. So it's AI in combination, maybe something like this. Is that what you meant?
But perhaps before we go into AGI, because I think that's a very interesting topic in itself, let's just finish up a bit about the stock trading part, I would say. Could you share some perhaps details about what system you have today, if you want to, or if you don't want to, that's fine as well.
So we've been working in my research group. So we have recently published a paper at the International Conference on Artificial Intelligence in Finance, where we developed algorithms to predict the price of portfolio and looking at basically as a time series. And we use some kind of, as all other researchers do nowadays, put together different architecture of deep learning.
But it's mainly technical analysis. It's basically using the time series and not like fundamental analysis or these kind of external signals, or?
Well, I mean, you have the time series of the prices, and what you do try to model using some kind of neural network based architecture, taken to count the time history. So it's in that sense, just, straightforward. It's just, how do you augment the data? You have small number of data. How can you extract more information that maybe the state-of-the-art techniques cannot do, etc. So it is, in a sense, simple. And, just trying to take off-the-shelf methodologies, change architecture a little bit.
And for the people listening that are a bit technically interested, how would you describe the method that you use? Can you go a bit more into depth in what type of architecture and how it works?
Sure. So it is it's a combination. We could use LSTM, for instance, and combine it with different tricks that you actually have that it's nothing special, and it's really, I wouldn't call it science in that sense. It's really trial and error. But this is just like all the other methodologies that actually get published. The most intellectual part of it, I would say, is more how we handle the data, and is that we combine the data in a nonlinear fashion. So, for instance, if you have a vector and you just want to predict if it's going up or down, so you have 1 or -1, and then you build another feature vector that takes, for instance, the product of two parallel series, and you create another series. So if you have like -1, 1, 1, -1, another one, 1, 1, 1, -1, you take the product of -1, 1, 1, 1, etc. Then you have suddenly another feature vector,
time series,
and you have expanded the data a little bit. And this, at least based on the data that we tested, seems to be give an advantage. So what does it mean? It does mean that you can actually make some nonlinear transformations to extract more information from the data. So in my opinion, this is really where the value is, rather than how we played with the architecture. We just, we got it to work. But
I remember I saw some article, I think it was in KDD 2018 or something, and they did this kind of AI in finance, and they wanted to evaluate the traditional stock trading patterns. I think, in stock trading, I'm not an expert in this, but they have these kind of weird names for, if it goes up and down, and then you have a certain pattern, and they have this kind of strange name, like the dying swan or the crying baby or whatever it's called. And if it has a certain pattern, then they basically buy or sell in some way. And they want to evaluate if that really worked. And they basically came to the conclusion that these kind of pattern is like more or less random or useless.
This is very interesting. Are you familiar with the mathematician Simons, who founded...
We actually have money from Peltorion from him, but yeah.
Yeah, so he's the founder of this hedge fund.
Euclidean.
That did beat the market every year for the last, 20 years or something. And there's a very nice book called The Man Who Solved the Market based on him. So he was actually... a star as a mathematician when he was young, and then he quit when he was about the age of 30 or something. And at least what he says is that at that time, the trick that you're describing, this is what worked. They discovered some patterns that were repeating themselves. Yeah. And what's actually, I think, what's more interesting is the story about the hedge fund itself, because it's not open anymore. It's only the employees that can invest. And that's because apparently if they become too big, then they will affect the market. And then their algorithms would not work anymore. So it works to a certain amount of money. I don't know if it's like $100 million or something. So it's not that big. And if it gets bigger, then...
they will actually shape the market.
They will affect the market.
So they will affect their own patterns.
So you need to work like in the shadow when no one is noticing. So this hedge fund is not public open anymore for now.
Yeah. He's a certainly interesting person. Cool. But, okay, so you had some kind of time series architecture that you had, and I guess stacked in some way to build up a...
Yeah, to be frank, I don't remember exactly, because we tried so many...
You just want to disclose it, right?
Actually, it's published, right? So it's right there. So if you Google my name, it's recent. You will see it on Archive, one of the top published articles. But frankly, I don't remember what architectures that were working, and I don't want to even like overvalue them, because this wasn't really it happened to work for the tricks that we did with the data. On the other hand, I can tell you about other things where I experimented myself, and again, there is something called, for instance, Brits. There's a paper actually also called Brits, which is how you can fill in missing data for a time series. And this is useful. So you could have a lot of noisy data, so missing values, and you would like to fill them in. And this is a very useful method. This is nothing that we've done, but this is published. This was a very useful thing. And using LSTM is actually very useful if you do it the right. So LSTM is very hard to get it to work. But if you're stubborn and you try many times, you could get pretty good results.
And if you were to redo it today, would you use transformers then, or how would you change it if you were to do it today?
It would be the next thing to do. I'm not saying that transformers would work, and it's not a bet either. And let's remember, it's all about how, again, so we know that training deep learning models is a non-convex optimization problem. And this is why we really get different results. So from a really mathematical point of view, LSTM has a more generic model than transformers, because it's really taken a finite history in time. For LSTM, it's a dynamical system with states in it. So the one is a special case of the other. But the difference is that the non-convexity makes it hard to think like I usually call it thinking linearly. You cannot, if something does not work for a specific set of parameters, it does not mean that it does not work. All we know that if it does work, then we're lucky. But if it does not work, we don't know that it will not work. So that's actually very annoying. Also for us, a researcher who really wants to, have scientific conclusions, that's very annoying. And I get annoyed about all the publications I see nowadays.
I think that's an interesting topic of discussion shortly. And I know you have a mathematical and control theory background, which is more into trying to find a proper mathematical modeling, and then machine learning is just this kind of trial and error with data and see what works, and can be a bit frustrating, right?
I would like to hear those two battle it out a little bit. Those two, but I think we need to do an introduction, Anders. Yes. So, who are you? Who is Adi?
My name is Ather Gattami. I have a long academic background. So I grew up in Lund, southern Sweden. I had interest for actually drawing when I was a kid. And I basically, math was easy, but I didn't find it fun until maybe I went to 6th grade when I solved problems, faster than the others in my class, and I started to get, to solve problems for higher grades later. But
so 6th grade, that's like when math is something that comes a little bit natural.
It was easy, but it was nothing that I thought about. It's, it was a nice subject because I didn't need to study.
Exactly.
If it comes to history, you really needed to read through things. But math...
that's for you. Not for all kids.
Math, I could sleep in the in the classroom. So that was nice. But then actually I got introduced to physics. And I found it, really. So, of course, I think like many of us... it's very easy to like science fiction. And suddenly, hearing about the theory of relativity, and you feel like, but this cannot be real. So science becomes reality, but it sounds more like fiction. So that was very interesting. I was interested in space, etc.
So you were the sort of the Stephen Hawking style physics, like the
I started to read Stephen Hawking at a very early age.
Yeah, so when did you read his A Brief Moment in Time? When was your introduction?
I think I was 15 or 16.
Same for me.
Yeah. I cannot claim that I understood everything. There are many things that, this is what he meant by that. But it definitely caught my interest. So that was, so it switched to physics. So I liked drawing, but then I thought I wanted to be an architecture because it's also drawing and it has some math in it. But then it was physics, and it was at a time I didn't know if I wanted to be a physicist or a mathematician, but was definitely physicist I wanted to be. But then at high school, I decided to study engineering physics because I thought at least if I want to work...
Not only academia.
Exactly. I can get a job as an engineer. So I ended up having a double degree, one in engineering physics and a master's in mathematics. And then I did my master's at Caltech, which was an amazing place. The choice was not random because Caltech, that's where Richard Feynman was teaching. I already had his books, and it had 25% of all Nobel Prize winners in physics in the US.
So you had a goal.
Exactly. So Caltech was the place.
Shortest route to Nobel Prize.
Definitely. Of course. I cannot deny that this was
an ambition, a dream.
Definitely.
That's cool.
So I did my master's at Caltech, and I got a little bit disappointed because that's where I saw that most of the research funding comes from the the U.S. Defense and American Air Force, etc., etc. So I was at the time working with. So that was 2003, and my research was about UAVs, unmanned aerial vehicles, so drones basically.
Drones, but they were not called drones by then.
That was long before.
What are you talking about here? 90s, 80s?
2003.
2003,
Yeah.
right? Yeah, exactly.
And it was very clear. It was like military purposes, because you want to have these UAVs flying in in a formation, trying to follow a specific target, and why do you want to do that?
What's the research purpose of this?
Exactly, and it became very clear.
What was the topic you studied at that time? Was it more control theory and really how to make them
fly
properly?
It was automatic control. As the name is, control theory, automatic control is about autonomous systems, and you want to design these decision algorithms to achieve a specific objective.
So you had not got introduced to machine learning at that point? Or?
No, but actually when I actually 2 years, so that was 2003. When I was a student, 2001, there were 2 books that caught my attention. That was Russell's and Norvik's book of artificial intelligence, and Papadimitrios' book on optimization. And I knew that I would not be a mathematician, but I liked applied math, and I saw that these were very central.
So now it's converging a little bit, like a theoretical maths. I don't see the purpose, but here I also almost see how my maths and my physics come together as something.
Precisely. So that's optimization. That's what I actually spend a lot of time working with, and artificial intelligence that I saw it was very central. But unfortunately, it was not hot at that time. So
this was a bit of a.
So from career point of view, it was not good.
But how? This is a stupid question, but how far away is this? What we're talking about here with the today toy part of buying a DJI Mavic Pro and having your drone that can fly and shoot camera and where you want it to follow you. How much is AI and how much is control systems?
So basically, all of these things I wouldn't call. I mean, if you have camera, of course, you use probably some tools from machine learning, like object recognition.
Object recognition for sure. Yeah.
So if you want to call it, that's a whole other topic. What is AI?
Let's leave that a little bit.
The short answer is that we don't know, because we don't even know what intelligence is, right?
Yeah.
So
we have many topics here that we have sent.
Yeah.
We've spent an hour with some guests on what is AI, what is intelligence. So let's keep them a little bit.
Let's leave it, because
now we're gonna get to them, but in time.
I'm pretty flexible. I mean, whatever. However you want to define it, it's fine. Just what you're talking about.
Yeah.
So in that sense, yes, the camera object recognition. Yes, we can call it. There's a touch of artificial intelligence.
Well, it's computer vision at least.
Yeah, exactly. So, but the control of the flying object itself,
yes,
is not artificial intelligence. This we have known for a long time. Is based on physical modeling. On the other hand, you could probably use reinforcement learning to improve on these algorithms. For instance, how do they behave? It's windy,
to adjust for the wind.
Exactly. So probably this is too hard to model, but you can actually have adaptive algorithms. So this is what's called adaptive control. Is exactly what reinforcement learning is.
And now it starts to merge.
Exactly. No, it's the same topic. It's really, I'm remembering.
Do you think Kalman filters are AI?
Again, so what is AI? I think not. So that's the thing. This is not the definition. And I'm also very careful, because I know there are many control theorists who would claim that they do machine learning.
And me, who doesn't have a clue what we're talking about on math level, what's the difference, Can we contrast control theory with deep learning theory?
Let's take that topic. I think it's a separate topic in itself. That's very interesting to take.
Yes.
But okay, so Caltech, and
let's move on.
I heard that you read the book from Russer and Norvig, which is, I guess, the most popular AI book that we have still today, right? AI, a modern approach, right?
Yeah.
And I know actually in your pod you actually interviewed Russell.
Yes.
I love to hear about that. That's actually a very interesting topic. But
now let's stay the course here so we can get
Caltech.
all the way. Let's follow a little bit so we can have these themes.
Yeah, so I decided to come back to Sweden because then I thought at least the funding is not does not come from the military. And I ended up at the control department in Lund, which is actually belongs to the top 5 control departments in the world.
Nice.
Why? Because the founder of it, Carl-Johan Åström, he is a recipient of the IEEE Medal of Honor, which is basically a Nobel Prize for engineers. So, and I remember even when I was a PhD student, people were showing respect that you did not deserve. I mean, even people from companies knew it because he has been visiting, etc. So that was actually it is an example. If you come from a specific place where your career could have a complete different course, I mean, you're privileged. I mean, there is no doubt that if you have been to MIT, Stanford, etc., you have much easier career path. And now in control, when it comes to at least to Lund University, that was something similar. Because that was it was the top control department in Europe, top 5.
Companies, they know.
Yeah, I mean, I have great friends at MIT, Stanford. I could go anytime, and I could probably get a guest office, etc. Because I still have my connections. So that was a great place to be. And then when I finished, I went to MIT as a researcher, and I had funding for 4 years, and this is actually where I discovered that machine learning is coming. I mean, that was really at the time, MIT was basically the sole place where you could see this kind of activity, and that was 2008.
And how was this? Is this before the brain drain or?
That was before the brain drain, definitely.
So how could you see? What was the signals?
The signals of
that ML is coming, or that is getting higher up on the agenda.
I mean, it's not like I could see this is the future. Mm-hmm. There's things that were really appealing with the problems they were solving. It wasn't this very mathematical, because we know that the real world does not work that way. So yeah, I can't explain why, but I thought this is the next hot thing. That was very clear. I remember the department where what's called CSAIL, Computer Science and Artificial Intelligence Laboratory. We were very close, and I got inspired. So when I got back, because I got funding from the Swedish Research Council, so I got 4.5 million crowns, basically to do whatever I want.
That's nice.
And it was nice. It was a bad decision, because leaving MIT was a bad decision. I mean, it's really one of the greatest places you can be. It was too early, but
you had funding at MIT, and then you got funding back in Sweden. Is that what you mean?
So
they lured you with money.
It's probably because for the professor title, that was I have to admit that it was definitely higher position in the hierarchy than it was at MIT.
So you're saying like the interesting place to be, and where they're cutting MIT in one hand, but here actually the next step in a career or?
Yeah, there are many. Yeah, and this is really one thing, and other things that I felt a little bit homesick.
But that's important to recognize.
It's important, but that was stupid. I mean, if I could look back, that was I was young and stupid. That's for sure. But at the same time, I thought, okay, I go back, I bring this knowledge. I wanted really to build a strong research group, put Sweden in the map when it comes to
great vision as well.
These fields. Unfortunately, in Sweden, we don't have the environment where you can be that visionary and definitely not start something new. And without giving, names, there was a colleague that really trying, making fun of machine learning, and this is this and this is that. And what happens now? The same professor goes and calls himself, I don't know, machine learning expert or whatever, which is really silly. And that's the problem. So that's really, we probably now touching on the topic, why Sweden is behind. I would say this is one of the reasons that people do not see it. We have a culture where risk-taking is not promoted, and people are happy with the stuff that they do. They publish their papers every year, and that's it. And that was not interesting to me. Just producing ink on paper felt extremely unsatisfactory. I really asked myself, what is my contribution to the world? But
could you then contrast that with the culture and how MIT, what the feeling and how the vibe at MIT to this?
You cannot compare it. You see, like the professors, completely different energy, completely different devotion to the topic they're teaching. The students all really target the hard problems. In Sweden, we target problems that we hopefully can solve. Doesn't matter how important they are. So it's more like paper counting. So you cannot compare. The environment. You have these recipients of all prizes. Von Neumann Prize. You have the future Nobel Prize winner in economics. You have. Yeah.
But still, okay, so you went to a big university in Sweden, KTH, which is not to be sneezed at least, right? Or?
What do you mean?
You went from MIT and got back to Stockholm and KTH, right? Mm-hmm. And I guess, if you try to still compare a bit, the type of university, like top universities like MIT to Swedish universities, I guess, as you say, of course, it's a different level of quality, which is undoubtable. But still, would you say there are some merits to the Swedish educational system that still is good?
Mm. It is unfair to compare. If you compare the Swedish educational system with the American, because the American educational system is not MIT. It's not Stanford. They have many universities, and it's actually few that are really star universities. So I think on average we're definitely better. I would claim. I actually have not. It's not based on facts. It's just a guess. So in that sense, talking about Swedish university. But if I really compare to universities like MIT, Stanford, Caltech, Berkeley, there is no doubt that there is no competition.
Yeah, and that's an interesting topic in itself, and how Sweden can start to accelerate the AI understanding and adoption in Sweden and Europe. But let's try to move on a bit about your interesting career as well. So you came back to Stockholm, and you started working as was it an assistant professor in KTH?
Yeah.
And what was your field of topic at that time?
So at that time, I was trying to merge decision theory with information theory, and I was getting into machine learning. And that's typically how you do it if you want to do research in a new field. You basically do it in your spare time. And during that time, I was working with decision theory, information theory, and all these things. These tools are very close to each other, but I never really did pure machine learning research. It took me about, I think, 5 years before I was able really to produce my own research output in the field. But my background, on the other hand, like reinforcement learning, my background helps a lot. So I have really extended some of the work that I've done before to machine learning. So I've been working with the so-called multi-objective problems, because in real life, you don't have just one thing that you want to achieve. You need to take into account other things. So if you are flying an airplane, it's not only about takeoff and landing, but you need to make sure you optimize your fuel. You don't want to crash. You don't want to have too much turbulence, etc. So you have multiple objectives, and this I have been very active and had maybe the most generic results in the field, and this is what I try to expand and take to the machine learning community, reinforcement learning, which is really very similar.
And you worked at KTH for quite some time, right? A number of years at least.
Yeah, 3 years and a half, I think.
And how did you get out, if you would call it that, or how did you move into industry? What was that story?
So I got in touch with Ericsson Research, and they were just starting doing research within 5G, the fifth generation communication system, which is finally out there. Yeah. So actually I started with it early, so I'm one of the main architects of 5G network for Ericsson. So actually it's record-breaking number of inventors for the 5G network architecture patent, 130. So that's
yeah, I've seen it. You have that patent. It's amazing.
Yeah, so that's a record, at least within the telecom
so you have
field.
So you have filed 130 patents around 5G or Ericsson?
And actually, I'm one of 130 inventors. We have 130 inventors because the 5G network is big. The architecture. So and this is a record number of inventors per patent. From a financial point of view, it's not good because you don't get any money out of it because you need to share the money with all the inventors. But
okay, now I understood.
Yeah. So so that
big
was
team.
Yeah, so that was fun. So the research. So I had a very nice research position, and after 2 years and a half. We were basically done with the research part. The next step would be standardization, and this was not as fun. So I got a couple of offers. I got an offer from Samsung. It was really, really great. Then I would move to Seoul in South Korea. I actually live in Gangnam, and I think it was it would be a nice experience. But then actually I got another offer from a company, a startup that was founded by one of my former colleagues, a professor at MIT, which I know pretty well, and I was recruited. I worked with them for a while, but we were supposed to have an office in Stockholm, but I had to commute to Boston basically 1 week every month, which makes me jet lagged 3 weeks a month. It was not worth it, so I decided to start my own company in Stockholm.
And that was the Bitdynamycs?
Bitdynamycs, yes. Yeah. So as you hear, it's really related to my background. I've been working with dynamical systems. I work with information technology, so it's Bit and Dynamics put together to be Bitdynamycs. So that's the story. And actually, we did pretty fun stuff. We started to build recommendation systems. And we had
can you mention some techniques? It is
some
always fun
customers. Yeah. So what we did is we use both deep learning. So basically, just to give you an example, if you have attributes, you're a person, you're a man or a woman within a certain age, you order something within a certain time, a certain day of the week, a certain day of the month, all these things, and you try to predict what's the next item that they would like to purchase.
So more of a content-based, not a collaborative filtering type?
It is collaborative filtering, because what we do is that it's clustered, right? So what I mentioned to you is not only personal. It could be any cluster of people of the same age, and but even take into account geographical area where they live.
Mm. Was it even using these kind of factorization machine type of techniques, or was that too early for?
Well, actually, when it comes to what do you call it, low rank matrix factorization, we did not use it for a simple reason. The problem is in general very hard. So it's an NP hard problem. So this low rank matrix completion is very hard. So I avoided that. Instead, we were relying either on deep learning or gradient boosting decision trees, who actually perform better than deep learning. This is an example where deep learning is not the best tool to use.
For the actual data problem you had?
Yeah, for the actual data, definitely. So what we tried, this was the better tool.
Was it like SVD kind of things, or what type of factorization did you make use of then?
We did not make any factorizations, right? Okay. Because I mentioned, I don't think it's the right tool. I definitely think that deep learning is a better tool, but in our case, even gradient boosting decision trees was even better. So
I see.
So that was fun. But what happened actually recently, 2 years ago, one of the guys who was helping me with the sales at Bitdynamycs, he has diabetes. And when he heard me explaining to him about this recommendation system, he thought, but couldn't one just build a system to help people with diabetes to predict their blood sugar and help them? Because he feels this is what he does every day.
Trying to figure out if I'm high or low, if going low.
Exactly, and this is based on recommendation system. So actually I decided to, although I had a customer, etc., and it was going well, no venture capital, we were self-reliant, decided to put Bitdynamycs on hold, and we founded AIbetics. So if you go to AIbetics.com, which is a really, really interesting company. We have been working on it for 2 years, and a release is planned for February. So this is an
recommend assistance for diabetics.
This is an example where the cause was much more important. Helping companies to make money. I like the mathematical problem, but the purpose
is not as exciting.
Yeah, but
this is cool.
But helping people, to have control over their life and be able to control their diabetes was much more attractive. So
this is
AIbetics.
Yeah. So as you're diabetic, like diabetic, and with AI.
And what and without giving the whole idea away, but what's like an app or something you use?
It's an app. I mean, the basic problem. So for it, so I learned a lot about diabetes because of this. First of all, the problem is enormous. I mean, 9% of the Americans have diabetes. In Sweden, is about, I think, 7%. And it's growing exponentially, unfortunately. So the problem is that you want to control the amount of glucose, like the sugar in your blood. Yeah. And people with diabetes, whether it's type 1, where you cannot produce insulin at all, or type 2, where you have a malfunctioning production, you want to keep the curve within certain bounds, upper and lower bounds. And when it goes over and under, not only you don't feel good, but actually it harms your body organs. I mean, it could lead to that you get blind. It could lead that you need to amputate an arm or a leg, etc. So it's really, really tough in many ways. Your life gets shorter, etc.
So if you're low, you eat sugar. If you're high, you have insulin. Like that's how you That's how you manage it.
Exactly. And if you're low, you want to have sugar, but you want to have the right amount.
Not too much to spike.
You don't want to take all these shots many times a day, etc. So you want to live your life as normal,
as balanced as
possible. And this is time series, right? So this time series problem. And what do you want to do? You want to predict these peaks in advance. And you learn. So we ask the users to interact with the app, take picture, object recognition of their food, and have it as feature to try to predict.
So how do you work as a user of the app? Do you basically, when you eat, you take a picture of it? And
exactly.
Then it predicts the amount of calories?
Exactly, yeah. And then you put it in, and then use reinforcement learning to learn, okay, what do you recommend? Okay, your blood sugar is low. Okay, you eat a banana to compensate.
And of course, you collect data from the patient, from the user. Also, how do you feel? Or now I'm low, so you can also get results on, you did this and you felt like this in 2 hours.
Exactly. You can really see what's happening, you can follow. And hopefully this data can also be provided to your doctor, so to be part of your journal.
Very interesting.
And this is actually something that is missing, and there's a big need of it. And we definitely think that we are doing the right thing, and this is really something that I strongly believe in. So this has been taking a lot of my time in the evenings and weekends, and there is another company which is really completely different. It's I want to solve my own problems, but I think this is something that you guys would recognize. So if you want that we meet, in a play, we email back and forth or text back and forth.
I can guess where this is going.
Right?
Good, yeah.
You want to do this automatically.
Yeah.
And this is, why I came up with Organize, and it's organAI.se with AI. organAI. It comes organize because we want to organize people.
.se. organAI.se.
Exactly. So we want to organize people's lives, and to start with, we want to make this booking to be very quick. So we use NLP. So this is interesting because just the problem of try to understand a query that you want to book a meeting with a person at a certain time, certain place, etc. There's so many ways in expressing that there's nothing that you can take off the shelf. So we've been working on this for over a year, modeling. So this is really one of our IPRs in that sense. And you just type something. Actually, there is a video you can see which demonstrates what you can do. And once you type it, it looks in our calendars automatically and finds common slots. If you give it the freedom to book it automatically, you don't need to interact. It does it yourself.
Or you get suggestions.
Or you can choose that you have to make the decision yourself. Yeah. So this is what I wanted, because I thought such a waste of time. You want to do stuff. I mean, we're having dinner with friends. The same thing. All the discussions about time.
You drop this in a large enterprise, and you can have a business case calculation easy.
I mean, we've received a positive response from many people. Actually, I have been the venture capitalist in the sense I have risked my own money, and we took also a loan from Almi. That's because I didn't want to have a venture capitalist as early as this stage. But for this spring, hopefully, I think we will go for larger funding
for
round.
market. I mean, like when you need to put the engine on top.
I mean, we have the basics. We are now currently building the app, the front end, etc. So we will have actually something working. But there are many more functionalities that I would like to have. That's for sure.
So you demonstrate this is working now, but have a look at this roadmap. How cool this could be.
Exactly. And we want to show them, okay, actually we can do this. All you need, you give us money not to realize a vision. No, the vision is already here. You give us money to execute, to go all the way to scale up. So again, I'm not that much into just raising money, trying to be big right away. Let's solve the problem first ourselves. Have something working, and then we can go. With.
And here we have another topic: should you bootstrap or should you get venture capital? Do you sell stories or do you sell value?
Yeah. I like selling value. That's the thing. I don't want to sound like I want to trick investors on money just because I can. No, look, I have taken risks myself. I have spent money on it myself, my time and actually money that I put in the company. So I was willing taking the risk, and we did make it happen. So just join the journey.
But so you've been keeping really busy. And at the same time, there is another part here. We if we want to go there, you are running a successful podcast as well.
Perhaps,
thank you.
We still have the career to finish, and I'd just like to add as well.
Is that not part of the career? That's not a career.
Before we finish with the organAI.
Organize.
Yeah.
That's a.
I mean, it's certainly. I guess the main part is really to give some kind of natural language input, and then find a schedule or a booking that suits someone. And there is another small company called Google that did this kind of duplex thing. I'm not sure if you've seen it. What do you think about it? It's a lot of controversy if it's actually fake or real, and it's been some part of it's deployed. But what's your thought about duplex?
I mean, it's very interesting. If it really worked, then that was a very nice example. I have no reason to doubt that is not real. I think such a big company, they wouldn't fake. I don't think so. But anything could happen. So actually, I never thought about that. This could be fake. I just, I bought the news right away. So it's very interesting, but it does not mean that we are really close to artificial general intelligence. Definitely not.
For people who don't know it, there is a famous video, I think at least 2 or 3 years ago, where they basically let the Google Assistant, basically, or the home assistant that you have, make a booking at a restaurant, and the only thing you say to the assistant is basically, I want to get dinner at some point next week. Please, make the booking, and they make the call and everything.
This is our vision. So this is where we want to go also.
Okay. Yeah.
So without sounding too cocky, we definitely want to be competitors to Alexa and Google Home, etc. But
couldn't you integrate with them simply, you think?
We could, but maybe we don't want to. And we shouldn't be afraid. I mean, we have seen like Instagram, how it really challenged Facebook, and it's more successful than Facebook. So you just need to find the right thing. What can you really solve better? I mean, even a company like Amazon, yes, they have a lot of money, but they have so many problems to solve, so many focus areas. So at the end of the day, to do something really good, they need to find an excellent team. And now, this excellent team, where should we use it? Should we use it to solve this problem, or do we have more important problems? I think they go to the more important problems. So that's why I'm never scared of that a big company could come and do this and do that, because they need to do the same work to put this team together. And I think that's the hard part.
I guess that's why Google says, they're not afraid about other enterprises like Apple or Amazon. What they're really afraid about is small startups that come up with the small innovative ideas. Yep. And I think that's so true. Okay, and before we move to AIPoden, perhaps you now work at Rise, right?
True.
So how was that story? How did you get started at Rise? And what is RISE, by the way? Perhaps?
So RISE stands for Research Institutes of Sweden, and it's actually a new entity. It was the government's attempt to collect the research institutes in Sweden. And when I joined the so-called SIX, Swedish Institute of Computer Science. And this was actually a very successful institute, very well known since the 80s. So RISE was official, I think, in 2018. And I got recruited because they wanted to have some kind of more research emphasis on artificial intelligence. So I was one of the core team, so to say, and I'm still like one of the core people.
So is this full time, 50%, or how does that work?
I started part time, but then they wanted to have me there more because I did other things like the AI conference called AI Day. And it's what we're supposed to have it in April, and it's like we had amazing speakers. Unfortunately, because of COVID-19, we had to cancel it. And the way I see it is that I think I'm gonna go back to working part-time now because not much is happening. We'll see. So basically, I was very excited at the time to join and build some kind of AI center. It was very early at the time. There was nothing basically. And
2018, yeah.
Yeah, it's actually 2017 already. Yeah,
already.
But now it's seeing more things happening. Now I've been at RISE for 3 years. So yeah.
And in short, RISE is a big like Swedish research institute with like 2,000+ people or something.
Yeah, I think
many fields as well.
3,000 people. Yeah,
3,000,
many
yeah.
field definitely. Yeah, it's big.
Mm.
But we need to spend more money in order. If you really want to build a research group within artificial intelligence with impact, you need to spend more money. That's for sure.
On research as a whole, or what would your advice to RISE be to get more progress in AI?
You need to have money. You need to have more
People, projects.
I mean, with money you can recruit people. That's the thing, and give people the freedom to do research, which is more open research. And to do that, you need to have real experts, role models who do a good research.
Yeah, it's not only about more resources, but the right resources and the balance of getting the fresh talent in, but having some real role models to mentorship to accelerate the breadth.
You need to realize how hard this is.
Yes.
When I say more resources, you need to realize that, for instance, at Caltech, I was visiting my supervisor at the time. We have good relationships. I visit him basically every year. And what he said that I think it was Uber who was opening a research lab just outside Pasadena. So that's where Caltech is.
Nice.
And that was, I mean, Caltech, MIT, they pay high salaries, higher than, I think the only university in the world that can match that is ETH in Zurich. And they felt like, but this battle is lost. There is no way we can match
Uber.
I mean, they pay 4 times the salary they pay a professor at Caltech. So what we can offer them at least that they work part-time, say 50% at Uber, and they work 50% at Caltech without having to teach.
Mm.
I mean, many researchers, they don't like teaching.
Interesting model, this.
Yeah. So they said at least this is one way to still keep them.
If you can't beat them, join them.
Yeah, it's like, yeah, I mean, so this is the only way. And this is something that I think in Sweden we have not realized that. I mean, not me. I think we have realized that around this table. But at companies, at universities or research institutes, they haven't realized that it's very easy. The last offer I got really and it wasn't a good offer in that sense. But just the last offer I got was 200,000 or 250,000 crowns a month as a salary. That's not matched by any university here in Sweden, not any close. So we need to realize that this is a different business.
And you think to avoid the brain drain that we're seeing from academia, which is happening certainly in the US at least, and partly I think in Europe as well, one way could be to have this kind of hybrid solution, you think? Or what's...
It could be. Definitely you need to open for paying higher salaries. That's one thing. We talk about if you want to recruit stars. Unfortunately, I don't think it's going to happen here in Sweden, because you really need, I think the government needs to come and say, okay, this is the money. Hire people, pay a salary of at least X crowns a month, really enforcing universities and research institutes to invest in people. I think that's the only way. But now, how do we get the politicians to understand? I know, Anders, that you are actually in
politics, unfortunately.
Yeah, exactly. In this context, I know I have also colleagues who are in this context, and the information I get that it's not happening. It's all like we've been getting promises for 3 years, but nothing is happening, and we are just behind.
Oh, so true. Cool. And let's move into AIPoden, as we say in Swedish.
Yeah, and by the way, is that part of the career, or is that just a pet project? Tell us about AIPoden, how it came about. I see it as one of the career moves.
Sure.
Or not.
I can tell you
because it's before Rise, I guess.
I tell you exactly. I tell you the story. So I started to write articles for the Huffington. So first, I started to write an article for Dagens Media, which I have a very good relationship with the guys, but they basically I didn't get any attention. So I don't think we even got a response. Then I wrote to the Huffington Post, or from Swedish to English, and that was published. And I published, I think, 4 articles about AI in the Huffington Post. And then Dagens Media
picked it up,
paid attention. Like, okay. And then
you could have had me first.
Exactly. So I think I wrote. I became a columnist almost, and I wrote a couple of times, and another, had specific writings about AI for recommendation systems, etc. And at that time, the managing editor Niklas Rislund asked me, would you be interested in making a podcast about AI? I remember we had lunch, and I think he wanted to see what kind of person I am. So he's a crazy person. It's a person that really could pull this off. And I thought, well, that's actually interesting. I've never listened to any podcast before. Actually, I just heard about it.
So 2017, this lunch takes place.
Exactly. It was, I think, August or September, something like that. And yeah, so I thought, this is fun. But then I went home. I told him yes. But then when it got closer, I started to regret the decision. But I felt like, okay, I said yes. It would be just childish just to say, no, I changed my mind. So I said, okay, I can do it for a season, and let's see what happens. Most likely I will not continue. And it started very simple. I started with, my laptop. I didn't know how to record. I got some help from people. Say, you can use GarageBand on your Mac, and they bought me a couple of microphones. Actually, we borrowed to start with. And it was terrible. If you would listen to the first 5 episodes,
I'm gonna do that now.
I mean, it's really at least I'm picky. I mean, you can hear the noise, and I was doing that. I never done it not even once in my life. I thought it was terrible. So I told them, but I'm not trained to do this. I mean, I needed feedback. I need help with this. You help me to do this. I'm not cutting the episode. You do this. And actually, I got help, and I'm working with these guys to this day. It's been a great relationship. But yeah, so we started, and they published the first episode at Dagens Media, and they told me that this has been the most read article for the week, and a lot of feedback. Congratulations! Actually,
nice.
What? Are they kidding me? It's like,
Nice.
I thought that they were just trying to be nice, but I realized, okay, this was well received. That's nice. What really surprised me is that it wasn't hard to get the so-called hot shots. So when I started it was at the time I want to make AI popular, to make the industry aware. So I thought I invite people from the industry who are starting to do something, even if it's something small, just to inspire people. People were really positive, and I got CEOs, etc. People really
is that the primary type of guest, or is CEOs the best type of guest?
This is what I thought, because I thought people would pay attention to people at high positions. And one of the first episodes was with the Nordnet's CEO at the time. And I think the trick worked, that's for sure. And then I started to move, so it was really CEOs or CTOs, something like, or CIO, or but then started to move toward. But actually, I also had a professor, Thomas Schön, was also one of my first.
He's a good person.
Yeah, so I tried to do a mix, and then started to move away from the CEO thing or CXO and more talk to expert. And then I mixed, and all of a sudden, when the director of engineering of Airbnb was in Europe, and they typically do marketing in different countries, and the Nordics, they had to pick. They had just one interview for the Nordics, and they picked AIPoden.
Yeah, so they sought you out.
Exactly.
That's super cool.
They reached out. They said, so we have...
this and this.
So we would suggest our director of engineering, who was great. I mean, you can see this is smart guy. He shared really interesting...
Professional, media trained.
It was so nice to talk to him, and he had, very interesting, cases to talk about within AI. And it has been very easy. Like, I had 3 ministers in Sweden. I had stars like Russell and
can't you tell us something
tell us about the Russell
one of the
story.
biggest stars in AI.
Yeah, and actually even other people I was very close to have, Bengio, but it was at the time, when he received his Turing award, it was too much attention, and he was very polite and apologized. I said, I need to do some research, and as a researcher, I could really respect his feelings. So so it's been really nice. So what has happened is that I have become more picky in that sense. So before it was every Thursday. Now this year, because of COVID partially, I think it has been very sporadic. Basically, if there is an excellent guest, then I do it. And I have not been active myself. I think partially because I felt that I didn't want to do it as often as I did before.
Just for the sheer commitment to have time for it?
Yeah, I mean, it's not, I mean, to be honest, it's not that it's a lot of time. Because I have a studio and the guys, do all this thing. But you need, to email a little bit before and you meet. And it takes some time and suddenly, half a day is lost. For many people would think, yeah, but this is a very productive day, which is. But I'm not a podcaster. It's not my career. It's not like I want to be Joe Rogan. Just take an example. It's really a lot of fun, but there is, for instance, I think there are more international forecasts who are more privileged. So if you're in the U.S., if you're at MIT, like there is this Lex Friedman, which is not AI podcast. Now it's more general.
At least nowadays. Right?
Nowadays,
yeah,
it is.
Yeah. I think he moved. It could be that he's not allowed to use the name of MIT anymore because the podcast is private. MIT has its own podcast. So when he was using it, using MIT, and he's at MIT, I've been at MIT, and I can tell you, the stars I had. My host was at the time director of Leeds, the Lab for Information Decision Systems. That's where Gallagher was, if you know him, like after Shannon information theory probably. And you had all these famous economists and physicists, he knew everyone. And I was in this big office. There were two other desks available. And they were sharing office with me. I did not need to leave the office to meet the stars. They came to my office. They did not come to me, but
they came to the
but nevertheless, they were in my office.
Same coffee machine.
I mean, not even that. I mean, I went to buy donuts, and I gave them donuts, and we talked, and it was a huge privilege. So
you mean that Lex and others have a big
advantage here?
It is. I mean,
to find the great stars for the pod.
They come to MIT. You just have if you're really intelligent enough and know how to deal with people, you can easily invite them over. Just say we can talk a little bit, and you can start with people at MIT. That's good enough start.
Yeah.
And you say, look, these are my guests, and you're at MIT. I mean, you have your MIT name in it, and that's it. So in that sense, it's extremely hard to compete. Now, if you want, so now you need to think, what are my ambitions? Is it like the AI podcast in Sweden, or do I want to expand? Of course, I want to expand. That's I mean, if you do not aim higher, you just there's no further development. So in that sense, I thought, okay, this is fun, this is nice. I do if there's some really interesting guest, I do it. But it's not gonna be my career. Actually, I've been many people thought, oh, you could really make this very big, this and that. And we have seen that if you just invest small amount of money, in social media, you get so much more listeners. Like if I just in a seminar, if I just mention my podcast, and you have like 100 people sitting, suddenly it's like one of the top podcasts on Spotify or whatever in Sweden. So you could do that if you want, but it's not really my ambition.
Cool. And before we continue, I mean, Steward Russell is, of course, one of the biggest stars in AI. And can't you share some kind of, what was the experience of interviewing him?
And how did you get him?
So, first of all, so he's at Berkeley, and I know a lot of people who are actually sitting in the same corridor as him, and was also co-authored books, and I think I just sent him an email. And I think I explained that we had some connection. Actually, I don't remember. I really need to look through the email. But I think it's possible that I wrote that we have, some people in common or something. And he was very kind. He said yes. I think I asked him maybe in December, and we had a recording in January, something like that. He was very, very kind. We had, real scientific. I think there was some stuff that we did not really agree on, but I wasn't trying to push it because I don't push, as you probably feel the same.
We want to push, but we haven't been so successful to push hard.
Yeah,
it's because it's a nice conversation and you don't want to ruin it.
Exactly, that's exactly. And at the end of the day, it's not my opinion that is important. I want to hear his opinion.
But you must share some example. What didn't you agree with him on?
So actually, this going back to my research field about multi-objective reinforcement learning, for instance, because he wrote this book, Human Compatible, and he's doing research about how to make sure that AI is aligned with the human interest. And my suggestion was that, but you need really to have multiple objectives. And what he meant is that even if you have multiple objectives, maybe it would prefer one objective over the other, and then try to goes back to fulfill the other objective, and then it's too late. I understand the philosophical reasoning, but I'm not convinced. He thought that it would be much better to have uncertainty in the task that the AI performs. So what does it mean? The uncertainty is that the AI does not know anything, so it needs to learn a little bit from how the humans have done things before. So even if it decides to bomb a city, it will probably not repeat it and bomb another city because it's, no, this is bad. It goes back because there's uncertainty. It's not certain. It will never be certain about bombing this city is the way to save humankind. So this is what he thought. And actually I read the papers and I see where he's coming from, but I still think that, if I think that this is an objective that you should not destroy humankind, it should really live up to it. I cannot see why it would violate it and then try to correct it, because if it's violated, it will never be able to correct it. So it's about formulating the right problem.
But let me see if I understand you correctly. So let's say you have multiple objectives. One can be that you don't want to destroy humankind, but then it can be other things. And I'm not sure if you're a fan of Asimov's laws or anything, but
Law of robotics.
Yeah, they are
the
questionable, I would say as well. But what do you mean that he prefers to have some kind of uncertainty measure in the objectives you do have, and in that way decide what to proceed with, and you think we should do it in some other way?
I'm not saying that it's the one way or the other. It's just that I did not really completely grasp why he thought that having multiple objectives is not enough. I did not. I wasn't trying to contradict.
Couldn't you combine the two and have uncertainty with multiple objectives?
You could, but I think according to Professor Russell that it's enough with
uncertainty.
That's my guess. I like I like your way of approaching things, because it's typically always probably combination of things that works. But if you go back to the podcast, I was trying to pinpoint. It was more like a question, but he was really insisting on.
Well, he was trying to be more dogmatic here.
He was really. This is the way. This is the way to do it.
This is the way.
Yeah.
But just, I think it's interesting philosophical question. So I think it could be worth to just dive a bit deeper into this question. And let's be concrete. Let's take some specific example. Let's take, I know you worked with truck platooning and things like that. And self-driving cars comes naturally then. And let's say you have two objectives. You want to get, quickly from point A to B. And then you have another objective of not killing your driver or passenger or people around you or something. And then you have these two objectives. What would you say is... Okay, let me speak in terms of Russell. And I probably paraphrase him a lot, but please disagree with me if you can. So then we can choose to have, let's say, two objectives. One, be safe. Secondly, be fast. Right? Let's just make it very simple. Two objectives. Fastly going from point A to B and safely not killing anyone. And then we want to still reduce it to a single loss function in some way, in a single objective at least, because we have to make an objective choice in the end. And that means having a single objective. Right? Please disagree if you don't agree so far.
Sure, go ahead.
And then the question more becomes, okay, how do you choose between the two objectives you have of safe and fast, so you can combine it to a single objective of what action to take, to brake or to hit the gas, I guess in this case. And then if you include some kind of confidence measure for the two objectives and combine them into a single objective with the confidence measure for the action you should take, wouldn't that still be the best way to go?
Could be. So this is it's hard to argue, because you need to define. I mean, we know that defining these things mathematically is very hard. So,
are you thinking like Pareto optimization kind of things with two objectives and finding the optimal
I mean,
one?
Pareto optimization is one way to handle multiple objectives, but it's not necessarily the way you want to do it. But it's definitely one way of doing it.
Yeah.
What's interesting is actually how would Russell model exactly this problem. Because the multiple objectives are so natural here that I think it's unavoidable. But I think what he is referring to is not multiple objective problems in general. What he's referring to is how to make AI learn the right things from humans and avoid doing bad things.
Yeah.
And he says the only way is that you introduce uncertainty, because it will always need to revise its decisions.
And you think he's thinking that from a Bayesian point of view of like level of knowledge that you have, or what's
I think so. At least from the papers that I read, it was really from a reinforcement learning point of view. So you have basically a process with states, and there's an objective that each want to optimize. And what you have is that you have a collaborative problem. You have the agent, like say the human, and you have the AI. Both try to optimize the same objective, but they're working together. So the human in the loop knows exactly what the objective is. The AI does not know what the objective is. So it has to observe the human to learn from the human what the objective is and learn from it. So and the human introduces uncertainty all the time. So the AI does not converge to one decision. It will need to really update its decisions all the time. So that's the idea.
Yeah. But okay, I have a hard time to understand what your objection to that is.
I have no objection. I have no objection to that. Again, what I was also suggesting that if he thought that also thinking of the problem as a multi-objective optimization problem, if that would help. Of course, when I suggest that, that's because it's something that I work with. And I thought it would be interesting to get his attention. Of course, in this particular example, I failed because he still thought that having the problem posed as a multi-objective reinforcement learning problem would not solve the problem.
At least if you have like single point estimates for each objective, right?
I mean, if you have two different objectives, I mean, we want to minimize the fighting or the number of wars in the world. At the same time, we don't want to destroy humankind.
I feel this is a discussion we should have after the podcast, but unfortunately you have to leave. But I could dive much deeper into this discussion.
I would be happy to have it over dinner or a beer another time.
Cool. And I'd just like to continue the podcast theme a bit more. And you mentioned a number of podcast people. Joe Rogan, of course, is the premier and most, I guess the person that makes the most money, at least, of podcasting today in the world. And Lex Friedman is one of the top AI podcasters,
I guess.
And there's a lot of other, like Eric Weinstein and Jordan Peterson and Ben Shapiro. Do you have like a favorite podcaster that you follow and really admire and try to perhaps see as a role model in some way?
Inspiration.
I mean, I don't listen to many podcasts, to be honest. I told you that I have been, playing with stocks a little bit. So actually, I have followed some more business podcasts. One of them is Mad Money.
Okay. Yeah.
I've seen Mad Money.
Yeah.
I've seen Mad Money.
Yeah. So
but that's random.
It's one of the popular.
He's pretty big in America.
Yeah, he's big. I'm not saying that. So okay, I'm not saying that he's so good or this is something that I listen to, but it is an easy way to get news. It tells you about what's happening. You listen. I work, at home with my computer, and I just, having radio in the background and. Getting some information. Actually, sometimes I probably miss half of the episode because I'm focused on the work I do. But I think when I started to listen to podcasts before starting AIPoden, because I wanted to know what is a podcast. So I got a tip from a friend about listening to Framgångspodden in Swedish, and I thought actually I really listened to several episodes because I thought it was very interesting guests. I did that, but then I got tired and stopped.
So what did you like about it, and what did you get fed up with, if like this? Because he's one of the biggest podders, influencers in Sweden in this sort of space business.
I like the people telling about their lives, how they got
interesting guests.
Exactly, it's about success, right? How do they get there? That's definitely an interesting story. But then it's different. I mean, I'm not saying that there are some guests that are more interesting than others, but it could be like some guests are more interesting to me than others. So I think he lost me after some guests, and he lost me as a listener. And I'm always interested in to hear about people, how they got there. Like, for instance, now I started to listen to the podcast what's called the Nobel Prize something, and they interview Nobel Prize winners.
That's cool. I missed that one.
Yeah, this sounds it sounds very interesting with all these Nobel Prize winners telling about their stories. So this is the kind of stuff that interests me. So it's a topic that falls within my field of interest.
So one thing is, of course, the guests, and that's perhaps the most important part of different podcasts. But do you, as a professional podcaster yourself, have any principles or ways that you prefer to be as a podcaster?
So again, I don't know if I'm professional. I'm proud.
You are. Of course you are.
Based on your track record now in Sweden, you belong to the elite. We think so.
Oh wow! Okay,
Yeah,
I didn't know
you're
that.
one of the podcasting elites in business podcasts for sure.
Wow, that's
We think so.
Okay, thank you. I never thought of the podcast this way. No, actually, so the principles are first of all, it should not have a commercial flavor. I have stopped a guest saying this is like reading a commercial.
Yeah.
You should not have salespeople doing
Not
that.
a sales. You don't want a sales
Yeah,
pitch.
exactly. No, that guy was not sales.
But he still did a sales pitch.
Yeah, that was actually, I got annoyed. Yeah, it was, I reacted in a way I could not control it. It wasn't like that tough, but it was very firm and decisive. This is like reading a commercial. This is not interesting. So
that's one of your key sort of where you come from as a principle.
Yes, so this cannot happen. We're talking about an interesting topic. There's so many things. I ask them to talk about their projects. What's new in their products? That's interesting. And they could get good attention or publicity for that. But not, we are a company with X thousand people. This is not.
But this is interesting because I kind of, we've had guests here who is working on really cool stuff, right? And like we showed your cool stuff now. But I think this is different. You're not pitching us on what you're trying to do, but we are still very keen to try to understand what's the value and the problem you're trying to solve. So if someone is smart, you can sell in quotation marks. You can explain what your passion is all about, what your value is all about. That to me that is okay.
But that's okay. But that's exactly what I tell them. What's
the problem you're solving?
Exactly. Tell us tell us about cases where you really found AI been very helpful.
Touché.
It's right to the point, but not general stuff. We are, using this, use our system. You can say, yes, we are solving this with AI. This is, this is cool. And actually, you can tell many interesting stories.
Yes.
I think now you're mentioning that, I really did not think about this was as a pitch, because I really thought these are really cool solutions based on machine learning.
So to the outside, it could be like, oh, come on, this is a sales pitch, just the other sales pitch. But to me, it's a huge difference.
It actually, I would have respect for people who would think that, definitely. But if you take my word for it, I really did not think actually about it this way. I just wanted to share these ideas because it's something I've been working with for 2 years.
Yeah,
of course, at some point I want to share it. So.
Yeah.
Cool. And besides that, there are different ways of conducting yourself. So it's one thing, what the guests are and how they speak. Do you have any thoughts about how you should act as an interviewee or interviewer, so to speak?
So I typically ask people for feedback, and of course they say, "You're excellent. It's good the way it is." I don't believe that. That's for sure. Maybe I think people appreciate that I let the guests speak more than I do. I think that do people appreciate. But actually, a very close friend, he has given me feedback on a couple of things. One, he said the episodes are too short. He's a computer scientist, so I'm not surprised. He said it's too short, and he thinks that I should talk more. He says that there's a lot of information that I probably have that could contribute to the episodes related to the guest.
But do you see it as you're doing an interview, or do you see it as you're having a conversation?
I think the problem is that I didn't think that much at all. So I'm not trained. I'm not a media person. and I was asking for feedback. Really, I was there to help me, tell me how should I do this. I said, oh, this is very good. So I realized now it would maybe have been more fun to have a conversation rather than I was trying to put the guest in the middle, so they get all the attention. I should not be in the picture. Maybe I clarified some stuff to the listener if there's a terminology or technical term. But other than that, I was trying not to be visible, which is maybe part of my personality, that to give people space. Yeah. When it's my time, it's my time. But when it's some other person's, I think it's good to give them some space. And in the beginning also, I think there are many of the guests who were nervous.
Yes.
Because, here I'm talking to a researcher within a field. And they were really, I could see they're nervous, or they could tell me right away. And that was, my way, by being more, just pulling back a little bit and give them space, was also part.
A way to make them relax.
Of the trick. But there are many ways. You can.
There's no right or wrong.
I mean, you can tell, but I mean, you can let people tell their story. You can have a talk. I don't know what's more interesting. I think both could be interesting, but I'm definitely not putting effort in that sense. We don't have manuscript, for instance. Nothing is planned beforehand. Not even, they asked about a list of questions in the beginning, then I had to put them together, but now I just insist that there is no list of questions.
What's your thinking about interruption? I'm personally a person that gets annoyed when I get interrupted, and I try to minimize the time I interrupt other people.
And I love to interrupt.
Yes, so it's very different people here. What's your feeling? Do you get annoyed when you get interrupted?
By the way, I did not. You have not interrupted
all the
me.
time. I'm interrupting you all the time, and I'm filling you in all the time.
I don't. I don't feel it that way.
It's like you're talking. You have a commentator. You haven't mentioned. Like I'm a sports commentator to what you're saying.
I have not. I have not noticed that.
I do it naturally. I can't help myself.
But I have not noticed that.
That's great.
I think it's interesting. Then you have. I think you have a conversation. I think no one likes to be interrupted. In general, I think as simple as that. Because when you get interrupted, your line of thoughts get interrupted, and you could say, okay, what was I talking about? So that's as simple as that.
Cool. I see the time is flying away. We have like 20 minutes, but we have a number of topics that I'd love to try to cover.
Topics, by the way.
So should we try to have a number of topics now, but try to keep them rather short?
So let's see if we can be disciplined, Anders.
And Goran is laughing now because we usually fail on this.
We usually crash on these. Yeah. Let's be speed dating is not our deal.
But okay, we have a number of topics. So let's try to cover as many as we can.
10 minutes per topic. So 10 minutes per topic. Five. Okay. Wow. Okay. Now we're going to go down into the whole. Now we're really doing YouTube 5-minute clips. Good.
Okay. Let's touch one topic first that we mentioned a number of times, and that is control theory versus like machine learning. Mm-hmm. And I had a friend myself that was doing his PhD at the same time as mine, and he was in control theory.
I'm measuring the time.
And then we had a number of discussion, and in some view, and I can give my view first, and I'd love to hear your reaction to that. But in some way, people in control theory think that machine learning in some way is very much a trial and error kind of science, or not even science at some point, more like engineering, perhaps some people call it, and not really modeling by theoretical mathematical way how things work. Instead, just trying to fit the data to some kind of model. And basically do trial and error. And they a bit think that's not very beautiful. Would you agree?
I definitely disagree.
Awesome. Okay. Can you elaborate?
Yes. Actually, I was thinking you would say that people within the field of control theory think that machine learning is just a sub-field of control theory. That's
how you would have put it.
So no, because it could be the other way. It's
Yes.
like, but what is funny, I think, so I've been in academia for a while, and so has Anders been. Everyone, look at a certain field from its own perspective, and they all say, "Oh, but this is just part of my field." So it's so. I mean, I've seen it many times, and it's not true. And it's not true that it's. It's trial and error because. I mean. We have non-convex optimization problems, so when you train these algorithms, you could get different models every time. So that's the reason. But if you really would search over the entire space, you would find good solutions. And it's as systematic as Fourier series or whatever, because also specific structure, and you try to fit parameters. I mean, this fitting thing is nothing new, and this is what we've been doing in science. So I disagree. Actually, this database model, I think it has just added a new dimension because, yes, if we know everything about the physical world, if we can put everything in physical equations, that's great. But the world is very complicated, so it cannot be as simple and beautiful as, simple equations. And I remember at NeurIPS in 2016, I met with an energy physicist, and he says that all the energy physicists are getting crazy because the models based on neural networks are outperforming all the mathematical models that they had.
Exactly.
So
it tells you something, right?
Yeah, so it's
a rethink that needs to be done.
Yeah, so it's definitely uneducated comments, I would say.
Wouldn't you also perhaps agree then that if you heard about AlphaFold 2, it's just released by DeepMind. So AlphaFold is about this protein folding thing where you map the amino acids sequences into some kind of 3D structure. And they had the first version, and it barely could compete with the physical modeling or the biological way of simulating basically how you calculate these kind of foldings or map it to a 3D structure. And now suddenly this version 2 came out that went from like 50% accuracy to 83 or something, and completely overtook anything else that you can do by trying to basically simulate the physical or biological world, and open up for so many use cases and finding the medicines and whatnot. So I think these are a typical example of, even though it may not be beautiful from a mathematical point of view, it may be super useful at least. Right?
I mean, I think it's beautiful in a sense that if you look at the theory behind it, and it's very well structured. I think the part that does make it a little bit ugly and messy is, again, that's the non-convexity of the problem again. But I mean, it's you look at the math behind neural networks; they're universal approximators, and telling you that. So that is actually a theory. Actually, if you really follow the theory itself, you see that you make better models. I mean, just if you normalize the feature vector, just as the theory tells you, you get better results if you do not normalize. That's why we do it in practice. So actually the theory tells you a lot. So I have to say that the mathematical bases are really interesting. They are impressive. Things are happening. We are seeing progress. So I'm a little bit optimistic. I think we're going to make more and more progress, and this is the way to go. I think. But
is it ultimately a science paradigm? That's like the convexity we're talking about that I don't even really understand as a layman. But to me, what I'm hearing as a layman is a little bit like, well, the world is a messy place. So let's find methods how we do deal with uncertainty and messy things, which is trial and error, but how can we systemize and be super smart with that? So the perfect theorem is a little bit, it took us so far, and the next level is something else, which is more closer to reality.
I mean,
is that wrong? Or?
No, I mean, no, I don't think it's wrong, not at all. I think that we have, many challenges. It could be that we are out of elegant, short mathematical descriptions of things. The more things become complex. I mean, just look at the three-body problem. That is, it's not that you think it's not that complicated in a sense, but suddenly it becomes more complicated. Just think, you put the things together, it becomes complicated. You need to.
And we had the traveling salesman
problem.
Do we solve it with the perfect mathematical theorem, or is it crunching, right?
So I actually have a very nice saying by my host professor at MIT, which actually he also took it from another professor, which is saying that just because the traveling salesman problem is hard to solve doesn't mean that salesmen stop to travel.
That's actually very good.
Very good.
Okay, let's move to the next
that was
topic.
not 5 minutes, by the way, guys.
Yeah. So another comment, there is this famous person called Jeffrey Howard, that I think he was the president for Kaggle at some point, and I think now he's a founder of Fast AI and this very popular website. And he made a statement saying that most research in deep learning is a complete waste of time. And just to give some context to that, what I at least interpret his, the reason for him saying that is, in deep learning today, it's a lot about chasing the leaderboard, about gaining like half percentage point higher in some kind of accuracy score that you have for whatever kind of prediction task you're trying to solve. And this is a big competition between the tech giants, and it's not really practically usable, that extreme type of competition for just getting on top of the leaderboard. Would you agree with that?
Maybe it's a little bit harsh to express it that way, but I definitely think that the way research is conducted is a little bit along this direction, which I don't think is that interesting. I mean, see all these new architectures of neural networks, and it works better. I'm a little bit maybe careful with such statements. I think I think most people agree that we have reached a level of saturations when it comes to deep learning. I think one thing is try to find new ways to use it. So applications, I think that's interesting. Like AlphaFold now most recently. Try to see, things within.
We have covered NLP. We have covered computer vision. Why can't we cover other problems?
Yeah, exactly. So just find interesting applications, and then in my opinion, the next step is to start to understand deep learning better and construct algorithms where the training is efficient. You do not need to spend so much
unsupervised
energy, or it's not spending too much energy. We need to understand maybe find some architectures that are still optimal, but that when you converge, this is the optimal solution. If you do not converge, then there is no solution, etc. Along these lines. I think these are the interesting, but these are the hard problems.
But how does that relate back to your little bit cynical comment around how we are chasing ink to paper in Sweden? If you compare it a little bit, like
the same thing. Right? Oh yeah, the same thing.
Yeah. So I mean, because getting on the leaderboard, improving on someone else's research is easy to get published.
I mean, by the way, I'm not saying this is a Swedish phenomenon.
No, not at all.
It is really international phenomenon. It's just that just because we don't need to import everything. I mean, it feels like we import everything from the US. I mean, we have definitely imported this way of conducting research from the United States.
So back to this.
Yeah, I think we need move to the next topic as well, unless you had something. Really.
Oh, now you're on 4 minutes. That's good. Let's. I was just gonna end. The end note would be like, okay, a little bit back to we touching this before, but like, what's our recommendation? How can how can we compete at Sweden University from this research point of view? What should we do that is sort of feasible when we don't have the same money as the biggest institutes? But how can we be innovative? I mean, I don't think it's about money. I think it's more about passion, and it's about daring and guts.
We do have,
and then
money.
we can do. Then we can do enough.
Yep.
So what is the advice we should do then? Not chasing into paper, not doing what Anders is highlighting. What's that?
I mean, first of all, in terms of money, we are very well financed. I mean, it's a very good system that we have, actually, and I cannot claim that researchers do not have the finances. On the other hand, we need to promote more risky research and do not really. So you cannot just judge based on the number of publications. You need to really start to look at the content.
What's the value of the problem? What's the usefulness? What's the innovation level?
I mean, there's no researcher that really has that many impactful papers.
So quality over quantity.
Exactly. But this needs to be read. I mean, the way you judge is you need to see what these people are contributing.
Cool. Okay. And to move to the next topic.
Next topic.
And we touched upon this as well, and we started to speak about reasoning, AGI, and things like this. So if we, how should we do this in 5 minutes? But okay, let's see. How would you say the difference between the latest type of AI today is compared to the human type of intelligence?
Oh, I think we are far from having artificial intelligence that can mimic human intelligence. I think actually we touched on this in the beginning. AI is not only about deep learning. We need to work a little bit on systems that can do some reasoning.
Yeah.
And
are you saying that reasoning cannot be done by deep learning?
I'm not. So the thing is that I think deep learning is part of it, but it's not the whole thing.
Yeah.
I think it would be a combination of things, as typically the case. And
would you say that reinforcement learning in some way is a form of reasoning?
Not necessarily. No, it could be blind, but reasoning is a feedback system, and I think that reinforcement learning is also an important tool, but it's not the entire thing. Yeah. So I think you need to have combination, and there's one more thing. So machine learning is about learning from data. I don't think that we are really doing the job required, because think about us humans. We take impressions, beyond numbers. So there are many things that need to be fed into a system.
This was interesting coming from a mathematician. Beyond numbers. What's beyond numbers?
Yeah, so it's not only measurements. You need. How do you? You probably. At the end of the day, probably you would translate emotions to numbers in a way. But what I'm saying is not only like simple measurements. There's more like human attributes that you need to take into account, and
they can't be expressed in numbers. Or?
Just to give you an example. So one of my favorite examples is that you want to teach an AI to recognize an animal. We talk about dogs and cats, but I like to talk about horses. And I give you pictures of horses. Okay. A whole horse. But actually, if you look at the back of the horse, so half the horse, not the entire, you look at the back, it's a horse. You look at the front, it's a horse. But these completely different pictures in a sense. And you basically need to, in a way, interact with the AI to teach it that this is the back of the horse, the front of it. So it's like you talking to a human being, like teaching a child. You need to interact with the system to teach it. So I think we will need to have some kind of system where actually humans teach the AI. And I do believe that this would be one of the future jobs that we would have. We have people, sitting, interacting with AI systems to teach them to understand the world better.
Are you a fan of Jan LeCun's kind of theory about how the future of AI should be? Speaking, going more and more away from supervised learning toward more self-supervised learning, and then I think the reinforcement learning is like the icing on the cake that he has. Have you seen these kind of metaphors or analogies that he's making?
I think it's one of the common attempts towards how we free ourselves from being dependent on data. And reinforcement learning still is about data. It's just that you collect it in a different way. You think about the interaction as a dynamic action rather than static. It's not only showing a picture and recognize an object. It's much more than that. And if you want to call it reinforcement learning, that's...
but I think the main thing he's promoting is trying to get away from supervised learning and only using unsupervised learning or potentially self-supervised learning.
I mean, what's the difference? You need the data anyhow. If it's reinforcement learning,
but then you need some kind of reward at least. But you don't do that for unsupervised or self-supervised.
The thing is, even with object recognition, you can describe it as an RL problem. Where
it still requires some reward. That's the big difference.
Yes, right? The reward, yes, but the reward is so it's called reward, right? The inverse of it is a cost. The same thing. You just have a minus sign as a cost suddenly. Sure. So it's the same thing. When you do prediction, you minimize an objective, and that's the error. So that's what I'm saying.
I wish we had a half an hour more too, because I think this could be a very interesting discussion to just dig a bit deeper into. But let me, in the manner of actually speaking more, I can give my few views on the difference between the human brain and deep learning at least, and let them know what you think about this. So I think there are a number of things that differs. One is that the human brain, of course, is online. We continuously learn and train all the time, and deep learning is usually very batch-oriented, and we train once and then use it. We can retrain it a couple of times, but it's very different from the online type of learning that the human brain has. The other thing is plasticity, basically saying that the architecture of the brain and how the synapses connect the neurons change over time. And neural networks does not, unless you use the kind of neural architectural search, and these have new techniques, but normally they don't. And that's a big difference, I would say. And then, of course, we have the reasoning and the generality that humans has that deep learning does not today. Would you agree with those statements?
So I think this could very well be correct, and it's probably also part of the story. I don't know. To be honest, I try to avoid philosophical questions. I typically think that everything is possible. You need to be open to all of kind of ideas, because you don't know if and when a specific idea is the right one. But you need to interact with people in order to have learned different ideas, and you probably apply the right one at the right time. But I think what you're saying is, this is how neural networks, it's inspired from the human brain, and we need to learn from it. So you're saying that actually when we learn stuff, we forget stuff, there are things that are changing in our brain, and it's something that we probably need to mimic. So that's what I'm saying. I think most likely it's part of the solution. And it's definitely worth an attempt.
And I think we just have a few minutes. I'm trying to choose the last topic we should do. And I can think, one is the AI divide, the difference between the tech giants and the rest of the world. It could be something about singularity, and when AGI happens, it could be something perhaps about patents, pros and cons. I know you have a number of patents as well. Which one of those three would you choose to?
The first one, I think it's something that...
AI divide.
Because I think it's a big problem. It's a big problem because, we have in general a big challenge with regards to big tech. And we know it's about the FANG companies.
Yeah.
And actually Tesla is joining now. Now actually it has been changed from FANG to a fat man, where
I haven't heard that.
where the G instead of Google is now as an alphabet.
A fat man.
Yeah. So a fat man now with the Tesla joining these big 6 big companies, and it is, I think, it's a challenge. Politicians trying to figure out how to deal with it, and if they have all the power about the AI, brain power and the technology in the future. I mean, if you do not realize that this is a problem, then you're missing something.
Yeah.
So you would say the big tech giants are far ahead from the rest of the world? Like, how many years ahead would you estimate them to be compared to
So first of all, they have a lot of data that even like researchers at universities don't have. I mean, let's not forget that neural networks were developed by professors, are still academic. But then this is the fundamental research, which is great. But beyond that, it has been total controlled by a few companies, and universities are definitely behind. Now, a guy like Benjo has decided that he needs to stay at the university because he needs to make sure that the talent also stays in academia. So he made a decision. That's great. But in general, it's hard to keep people when they offer
4 times, 5 times.
Not only salary, they give you a research team. You don't need to think about anything. I mean, I've been to Google, I've been to DeepMind. I mean, oh my God, it's really amazing places. I never thought that I could see research places that are better than the top universities in the US. But I definitely see that. It's uncomparable.
So you have a motivation on so many levels why you want to work there.
Yeah, so I think that it needs to come from at the state level. The politicians need to understand that these people are not only researchers. It's like even big companies, other than the big tech companies, probably should help to build such a research center where they attract people as a counteract to these big tech companies.
So that's the best way to try to solve it?
I don't know if it's the best way, but it's definitely a way to solve it.
And how would you describe why is the AI divide a bigger problem than maybe some people recognize? I think all of us who's in the industry and starts really understanding this and sees this is the new rich and poor. This is the segregated world, but on a much grander scale, much more extreme than we've ever seen. Why do you think it's so scary?
I think it's scary because information is power, and they have so much information about us, and then they have this intelligence system that can do so many things that we cannot figure out. So they will be ahead miles from us, and you will never be able to catch up. Doesn't matter.
And what's the consequence of this to society?
I think the consequence would be is simply that you get money centered around some companies that probably outperform even countries. I think is it Google whose revenue was bigger than India's or something? It was something like that. I mean, you can look it up.
Amazon has larger GNP than many big countries.
Yeah, so it's and that in Amazon it has certain reputation about how it's treating its employees, etc. So it's not. I don't think it's a good thing that is. Coming out of it.
I mean, it's certainly a big problem. And I remember when I was at DeepMind and they basically asked the question, why don't you patent? And they said, or why do you publish, all your models and all the articles and the data and the code and everything? And I said, Well, at the time we actually get the publication out and we have the code out, we're 2-3 years ahead, and we are already on version 2 or 3 behind that. So, good luck trying to catch up with us. And yeah, that's a dangerous story, I think.
Yeah. Yep.
Cool. I think we need to start to round up a bit. Yeah. And as the first, or one of the last questions, I guess, what's next in your life, Ather?
It's actually a very big question. I take it one step at a time. Especially with these times, I'm trying not to mention COVID. But
we actually didn't talk so much about COVID today.
But yeah, that was very good. I was trying to avoid it. But the truth is that, as I describe it, life is going in slow motion. That's how it feels. For me at least. And of course I have stopped by a little bit and thinking about what I want to really do in life, and giving me some
what are you going to be when you grow up?
Exactly, clear pinpointers. But I think research within AI is very interesting. Frustrated about I don't think that we do have the right, what do you call it? We don't have what is needed to really pursue great AI research.
The right ingredients in the soup.
Yeah, I mean, it's a lot of things. You need to have momentum. In Sweden, I know, Anders, that you don't like that people are criticizing. You still feel like there are things happening. I don't.
This is the after work discussion we need to have.
I don't share the same feeling, so that's annoying a little bit. And but what I'm happy about that actually I'm doing other stuff, at least where more like applied.
You have some exciting things you want to put in production right now.
This is
to put that in production.
This is what excites. Yeah, this is what
cool.
Exactly. So this is really what excites me, at least in the short run.
Sounds good.
And when does it? When will we see it in the flesh, in the wild?
So hopefully, sometime next year, by the summer, I would say.
Yeah,
definitely.
And when will you start chasing people for your big dream, in terms of support?
Oh well,
next year.
It's I think it's maybe March or something. It would be a reasonable time.
You heard it here first.
Cool, Ather. Anyone that you would recommend us to have on this show?
Oh, I guess you would like to have someone that could come to the studio.
Yes.
And
so probably
preferred.
Not American, but
yes. Here in Sweden, there are probably a couple of people. I would say Kalle Åström would be interesting because he has been working at computer vision for a long time.
In KTH? Or?
He's at Lund
Lund
University, and I think he is a good speaker. I think he does interesting research, and I would definitely recommend him.
Kalle Åström.
Kalle Åström, yes. And that I would say. And hopefully, I don't know, if we manage to have this AI day, I'm sure that you'll have several interesting guests that you would like to interview.
Yeah, so we would do a collab.
So I think you should keep track of it. I mean, as soon as we open up, we'll probably have.
This is the same AI day as we were. I was part of that, I think, as well. It was when we planned to have Smithuber coming, right?
Whom?
Smithuber?
Smithuber.
The LSTM guy. It doesn't matter.
Who was the main stars that you didn't get in April?
But that was probably before, because the AI day was even before my time at RISE.
Okay.
Probably.
So we were planning to have an AI day in the beginning of this year. As well, I think RISE was organizing it. I thought that was what you mentioned, but okay.
Yeah, that was the one. So if you look down, you can see probably my name as the chair or something.
Oh.
Yeah,
but do you have some nice names like Stephen
right.
Boyd?
Yeah, I mean these are really giants within the field. We've been working on this for a long time, and when COVID came, that was really
changed the world in so many ways.
Definitely.
That's for sure.
Well, we have so many more topics.
It's been a true pleasure to have you here. I hope we have some more opportunities in the future to discuss more, and I wish you could have stayed for the after work as well, because there's a lot of other discussions I wish we could have.
Thank you. Yeah, I would be more than happy. I mean, I would be happy to come back, and we should definitely have the after work discussion at another occasion.
And we are just waiting here when we can have a true AI after work, where all the guests who has been here, we have an after work everyone together, and we can do, but we need to be, so we can have the whole guest list at once. Like, that would be super cool. Really cool party.
Cool. Yeah.
Really cool party.
Yeah, definitely.
We're gonna go that way as soon as COVID allows us.
Cool. Thank you very much. Have a great evening,
Thank you.
everyone.
Thank you for having me.
Cheers.
Great pleasure. Thank you.